Welcome to simplifying radical expressions containing negative numbers. So one thing we need to know for this is anytime you get a square root of -1, that is the same thing, not times. That is the same thing as I. We're going to replace that with I, just the letter I. This is going to stand for an imaginary number. So let's get started. We're going to divide out the square root of -1 and make it I. So I'm going to break up, really just concentrate on what's underneath the square root here. And I'm going to break it up so you can see all the different parts. We have the 3x squared is on the outside. That's going to stay on the outside. On the inside of the square root, the -72 can get broke up into the -1 and a +72, and then x to the 6. We are then going to make this look, so we have the 3x squared on the outside. I'm going to break up the square root to both, or to all the different parts of the multiplication. So -1 squared root of -1 times the square root of 72 times the square root of x to the 6th. Now, looking over here, we have the square root of -1 is always going to be I. So if you ever have that, you can replace it with I. So we're going to make that I. So it's going to become 3x squared I. And then I'm going to have the square root of 72 and the square root of x to the 6th. Now with the square root of 72, we're going to figure out what the biggest perfect square that will divide into 72. So we have 4, 9, I forgot 16, or 16, 4, 9, 16. And so I'm going to figure out 72. 72, does it divide by 4? Yes. Does it divide by 9? Yes. Does it divide by 16? Yeah, no, it does not. 16, 32, no, it does not. 25, no. 36, yes, that's 2. 49, no. 64, no. And 81, no. No, no. So 36 is your biggest. So we're going to take the square root of 72. That's my concentration now. I'm going to concentrate on the square root of 72, and I'm going to break that into two different parts. So we have 3x squared I. Square root of 72 is going to get broke up into the square root of 36 times the square root of 2. 36 times 2 is 72. Hopefully you're following me. And then x to the 6th square root. We then are going to break this down further, and we have square root of 36 so square root of 36, I'm just looking at my notes. Square root of 36 is 6. That's going to come out. 3 times 6, x squared. Now I haven't talked about the square root of x to the 6th. Square root of x to the 6th. Think about how many pairs. Square root is like 2. So think how many pairs can you take out of 6? X to the 6th, and that is 3. Or you could take 6 and divide by 2, and that's going to be 3. So it'll come out as x to the 3rd, and then the I, and what's left over is the square root of 2. So we're going to multiply 3 times 6 is 18, and then x squared times x to the 3rd. You're going to add exponents when multiplying like bases. I square root of 2. That's our final answer. Alright, I'm going to choose a couple problems here to work out. I'm going to choose the ones that typically are some of the harder ones to work out. So I'm going to start with number 3. So I have 3 on the outside, and I think I'm going to break this up into -1 times 48. And the square root of -1 is I, and the square root of 48 we got to break down. So we have 3i square root of 48. 48, what's the biggest perfect square that can divide it on 48? And that's 16. So we have 3i 16 times 3 is 48. And the square root of 16 is 4. So that's going to be 3 times 4. And we don't know the square root of 3, so we're going to leave that square root of 3. That is not a perfect square. 3 times 4 is 12. I square root of 3. That's your final answer. Alright, I'm actually just going to do number 4 right away. So number 4, we have the 7xy negative 147. What is that? The biggest perfect square is 49, so that's 49 and 3. X to the 4th, you're going to think about how many pairs come out of x to the 4th. And coming down here, we have 7 times the square root of 49 is 7. And then the square root of, we have times x. And the square root of x to the 4th is x squared. You're dividing the exponents by 2. So it's x squared. What's left over, well, we have the square root of negative 1 is I. What's left over is just the 3. So let's get this together. 7 times 7 is 49. X times x squared is x to the 3rd. I square root of 3. All right, let's take a look at number 6. Number 6, the square root of 196. So that's negative 1. Actually, 196 is a perfect square. That is 14. And then we have x to the 4th and y to the 7th. So breaking this down, we have negative 5. Square root of 196 is 14. Square root of x to the 4th is x squared. Square root of y to the 7th. You can, how many groups can you take out of 7? Well, there's 3 that you can take out, and there'll be 1 left over. The 1 left over is going to stay underneath the square root. Wait a second. Oh, this is supposed to be y to the 3rd, y to the 3rd, y to the 3rd. It's like, why do I have an x there? My bad. And oh yeah, don't forget the I, the square root of negative 1. So we have 14 times 5 is 90. Nope, 70. My gosh. X squared, y to the 3rd, I, square root of y. And let's do number 8. So we have 7x square root negative 1. 16 is a perfect square, so we don't break that up. X squared, that's going to be an even exponent, so we're going to divide that by 2 into 2 or 1 group. And x y to the 8th is also going to be all divided out into 1 or 4 different groups. So we have 7 times square root of 16 is 4. Square root of x squared is x. Square root of y to the 8th is y to the 4th. Don't forget about the I. And there's no square root left. Everything got divided out evenly. So we have 7 times 4 is 28. X, y to the 4th, I. So come to questions with any questions.